This is problem 1, force acceleration 2, and we have 2 grade release from breasts, and the mass for A is 40 kilogram, and for B is 30 kilogram. And the coefficients of friction between the grade A and the inclined surface for the static friction 0.2 and kinetic friction is 0.15. The question is, what is the acceleration of grades? Acceleration of the grades. So they have a force, frictions, and the acceleration. So definitely this is a force acceleration method. And because we already familiar with how to start the problem, first classify motion. So I write down to save some time. So classify motion, and you can see block A slide on the inclined surface without any rotation, so it will be translation on the inclined surface. B is vertically drop down, so no rotation, so it also translation in the vertical axis. So with that, we have both translation properties. They give you a mass, so we need to find out the weight. So for the force, and we also have mu sub s equal to 0.2, and mu sub k between the grade A and the surface is 0.15. So how many bodies do we have in this problem? As you can see, it will be 2, right? So for the force acceleration method, if you have 2 body, break that down into 2 bodies, 2 separate body, and then each body draw 2, make them equal. One side draw free body diagram, and the other it will be kinetic diagram. So we can break down, and we have grade A and grade B, right? So let's talk about the diagram for A and B. Let's write down here. So as you can see, diagram for grade A, So we have free body diagram equal to kinetic diagram, free body diagram equal to kinetic diagram. And for one grade, we can make it 2, make them equal. So, and if it inclined surface, keep that inclined surface. So we have grade A on that incline. Write down that grade, make them equal, and that same grade A. Okay. So on the left side, we draw free body diagram. So if here we have the weight for sure, and that is 392.4 Newton. Have to be Newton, not mass. And we also have the normal force perpendicular to the contact. So we have N. And we also have friction. So you see it release from breast. So for sure, the grade A, it will be sliding down to the right. So the friction should be opposed to the motion. So what we have is go that way, friction force. And we separate the two body. We have the cable there, So we have to put the tension to grade A, and let's make that a T. So that is the free body diagram for grade A, and this is 20 degree. Yeah. Similarly, we have 20 degree. Now for the kinetic diagrams, this is a translation, so you don't have IG alpha, because IG alpha when the bodies have some rotational motion, and it's only slide through the parallel axis, the one that inclined surface. So as you can see, we will have the components is in one way at G, so it will be M A G parallel. So let's make that is M, in this case 40 kilogram, A G parallel, because inclined surface, so we don't choose X and Y, we choose parallel and perpendicular. parallel perpendicular axis. This block don't jump up and down on the incline, so you don't have MAG perpendicular. It's not rotation, so you don't have IG alpha. So that the only one term in the kinetic diagrams. And the box, as you can see, sliding down. When the body is sliding, the friction is not static friction anymore. It becomes a kinetic friction, mu sub Kn. So let's write down. We have it because sliding. So you will have the since. You can write here. Since grade A is sliding, so you will have friction force. If it's not sliding, impending motion, so it's less than or equal to mu sub Sn, but here it already slide, so it will be equal to mu sub Kn, and mu sub K we already have there, 0.15, so it will be 0.15 N. So that is the friction. So let's write the equation that we have in here for yes. So let you can have the equation with the perpendicular and parallel, but not moment equation because it's only translation. So let's write the equation of sum of all the forces in perpendicular, and let's choose up here equal to 0. This you can find out the normal force. So here we can have that equal to, this is 20 degrees, so that angle will be 20 degrees. So you have n minus 392.4 cosine 20 degree and equal to 0. Now let me rewrite there. Why it equal to 0 I explain later on, but let's do there equal to MAG perpendicular. So from that, from the kinetic diagram, we can see that in no MAG perpendicular, so it will be 0. So make that, clearer for us all here. So when you have that, that is one equation, one unknown, so you can find out the normal force, and that normal force equal to 392.4 times cosine 20. So you will have that is the normal force for that one equal to 369 Newton. 369 Newton. And then you also have the equation for parallel. So sum of all the force in parallel, sum going down equal to MAG parallel. So from that we can have T. We have the friction force negative mu sub Kn. So friction force. Let's write down. And then you also have plus 3, the weight 392.4 sine 20 degree. So that all we have on the free body diagram equal to MAG parallel. So it will be 40 AG parallel. And from that we can plug in, as you can see from here, you can have N equal to 369 and 0.15. So you have the friction force for kinetic friction, 0.15 times 369. So you get it 55.3, 55.4 Newton. 55.4 Newton. And from that we can replace that with the 55.4 Newton for the friction force. and then we can simplify that equation as, so like that. I can have that equation parallel here, equation 1 with this. It will be t minus, put the 40 Hg parallel on the left side, so minus 40 Hg parallel, put negative 55.4 on the other side, it becomes positive, plus with minus with this 392.4 side 20, so we have the negative number 78.86. 86. And as you can see, this equation is two unknowns, so nothing we can do with that. But keep in mind, we have another body we have to write out, right? You see one equation, two unknowns. We cannot do it, but we draw another diagram for grade B. So let's draw that down here. Diagram for grade B. So for grade B, so similar two blocks. Block B, we can draw two equal to block. What does that mean? Free body diagram equal to kinetic diagram. And as you can see, it will be the tension go up and the weight going down on the free body diagram. Excuse me. Tension go up T, and it will be the same T. We have it here because that's the same cable. The pulley is frictionless, so it only change the direction of the cable, but not the magnitude, the tension in the cable. So same T, and then the weight in that case for B is 294.3. 294.3 Newton. And for this one translation, so and it only invert vertical, so you have MB, A, and you see MA, by the way, MA in this case equal to y direction, right? Only go to the y direction. If you want to select that the x and y, and going down, so we have that, and we can make it equal to 30. That is the mass of B, and a y. So from that we can have equation for this diagram grade B. So you can have that is equation sum of all the force in y direction, let's assume going down, is positive and equal to MAGY. We don't have MAGX because the translation in vertical. So from that we can have, as you can see, 294.3 minus T equal to 30 AY. And that we make that it equation 2. So bottom line, we have two equation, and it's positive because I select, as you can see, going down, and MBAY going down, so that way it's positive there. So two equations, let's count how many unknowns. T 1, HE parallel 2, and this one it is the same, right? And then AY, so 3. So as you can see, we have 3 unknown, 2 equations. What can we do? We draw another body diagram, another diagram? No, we don't have any other body to drive. So assume something? Not in this case, because we already know the grade A is sliding, so you already know that. Just one thing that related to problem 2 in force acceleration 1, when you have two body, they work together. Grade A and grade B moving together. That's why you need to find out the kinematic relationship between the two bodies. That is the key word, right? Kinematic relationship. Kinematic between the two. relationship. And in this case, as you can see, they move together. So what do I have? If A accelerate down vertically, now if B accelerate down vertically an amount, call it A y, something we define here, then A, it will be slide on the inclined surface with the same acceleration AG parallel. Those two have to be the same, just like you and your partner, girl or boyfriend, hand in hand, walk in the same pace, regardless of you or your partner go with the same acceleration, you guys will have the same acceleration. So that with that we can have here AG parallel for the block A. It should be equal to AY in vertical for block B. So from that we can set up. So let's replace AY to become to AG parallel. So we can have that equation set up for 2 in here. And as I run out of the page, so don't want to get another video, waste of your time. So I have 1. So it become T minus 40 AG parallel equal to negative 78, 86. And then equation 2, I replace AY with AG parallel and I kick on the other side. So what I have it equal to T, kick T on the other side, plus 30 AG parallel when you plug that in, right? So equation 2 equal to 294.3. So that two equations, 2 unknown, if you just subtract 2 equations together, you can find IG parallel. So let's do that there. Here we already done. So these 2 equations, you can find out T equal to 134 Newton. And the question asks is G parallel equal to AY, and it equal to 532 meter per second square. And that should be the answer. If you want the direction, then AGY will going down vertically, and AG parallel, it will be inclined surface 20 degrees. And with that, we solve for the problem 1 in force acceleration 2.